In the name of Allah, hello students, welcome to our class today. I hope you are doing great as usual. As I said to you students yesterday, today we will start our lesson from a great question and also an enjoyable question. How an IC or integrated circuit is made? What's your answer students for this question? If you have any answer, please share with me in the group or in the comments. As you know students, and also I think students that IC name is familiar with you. As you know, students, the creation of a microchip is a very involved chemical process. If you want an excellent explanation and look at how an integrated circuit is manufactured, visit the How Microchips Are Made website provided by the Intel corporations at this website. Please search in this website and get your information, your needed information. However, here is a brief summary of what happens in this process that we will explain them one by one. The first one, students, acid crystal is slowly dipped into a molten silicon bath. As it's slowly extracted, it grows into an ingot of porous silicon that is grown into a perfect cylinder. A very thin wafer is sliced from the cylinder and polished. The next one, students, the wafer is exposed to some gases at very high heat. Students, this allows a very thin layer of silicon dioxide, like rust on metal, to form on the wafer. The next one, students, says the wafer is coated with a chemical called photoresist, which is resistant to ultraviolet or UV light, and then dry it. The photoresist is softened when exposed to UV light. The next one, students, says, or the fourth one is a stencil mask is placed over the wafer and it's exposed to UV light. The parts of the wafer that are not shielded by the mask become soft and gooey. Solvent is used to remove the soft photoresist material, leaving behind the pattern created by the mask. The next one, students, let's go ahead. The next one or the fifth one is the next bit, students. Okay. The exposed silicon diode is removed with other chemicals, which exposes the basis silicon wafer in those places left open by the mask. The remaining photoresist is removed, which leaves ridges of silicon diode where the mask shielded the wafer. The next one, students. The next one, the wafer is covered with a layer of conductive material called polysilicon, which is used to connect the layers of the circuit being developed. The next one, students, is another layer of photoresist covered the wafer and is battered in UV light through another mask. When the photoresist is removed, it exposes areas of the silicon diode and the polysilicon. Okay, students, let's go ahead. The next one, students, is, or the eighth one is, or the eighth step is the wafer is blasted with ions, a process called doping, which changes the exposed areas of the wafer to either conductors or insulators. Conductors and insulators, if we explain it, the conductors and insulators in the above parts completely, I'm sure you are familiar with them. The next step, students, is okay. That's the next page, students. Okay, the ninth step or the next step is steps 3 through 8 of this process are repeated as many as 20 times, depending on the complexity of the circuit, with small windows left open between the layers. The next one, student says, the metal is applied to the circuit, which flows down into the open windows and connects the layers. As you know, students, the circuit's wafer actually contains hundreds of separate circuits. The last step of the process is to cut the wafer into the microchips. The chips are then packaged with wiring to connect the chip to the pins of the packaging, and the integrated circuit is now ready for use, and also you can use from that. You must go 10 steps, and you after going and rounding the 10 steps, the circuit will be ready to use. For a more detailed explanation of how a microchip is manufactured, plus some other very good information about the history of integrated circuit, visit this website, and it will be helpful to you. Okay, students, let's go ahead. Okay, students, transistor. Transistor is very important, students, in the technology, because coming or becoming or involving or making the transistor change the world of the technology. As you know, students, the size of microprocessors relative to their computing power is shrinking every day. This is largely possible because of the technology advances that allows an increasing number of microscopic transistors to be placed closer together on a circuit. In the 1960s, the transistor paved the way for radios, calculators, and other electronic devices to become very small. We are the earliest computers filled up uh, gymnasiums and had tens of thousands of vacuum tubes that we had discussed about the vacuum tube generation of computers, or the first generation of the computer, and I think in the first semester in the computer fundamental book. If you're interested in that, please visit and read the computer fundamental book. Today, a billion transistors would fit into a single vacuum tube. The transistor is the primary circuit in a microprocessor and is used in several different ways. But its basic function is to store the electrical voltage that represents 1 bit. A transistor works something like an electric light switch, in that it either has a high electrical charge on, or low electrical charge, or off. However, unlike the light switch, the transistor has no moving parts. Its charge is set electrically on or off to represent the ones and zeros of binary values that we had discussed about the binary values, or on the binary system number in the above page. But also we explained the binary numbers in the computer fundamental book. If you're interested in that, please read the computer fundamental book related to the first semester. The number of transistors including in its circuitry determines the capacity of the processor. Modern microprocessors include millions of transistors, which is the source of their computing power. For example, the Intel Pentium 3 contains nearly 10 million transistors, and the processors used in the large mainframes and supercomputers have a billion of transistors. Students, is shown in the figure as you are seeing in your computer screen or your telephone screen, and the transistors have a different size, and they have a little size, and also they have a big size, but the usage of them uh, relative to the relative to our work, where we use from that. Okay, students, let's go ahead. The next one, students, is storing electricity. As you know, students, transistors store a bit value as the electrical voltage. The amount of electrical power used in a transistor is not very large. Most of the earliest microprocessors used 5 volts of direct current or DC, and the newer processor now use as little as 2.2 volts DC currents. A transistor stores data by switching between high and low voltage, which represents the binary 1 and 0 respectively. For example, in a 5 volt DC volt or 5 volt direct current processor charge of plus 5 volts the high voltage and represents a binary ones, and a charge of minus volts is the low voltage and represents the binary 0. One problem with using a higher voltage level to store a value in a transistor is that switching between these two voltage values as much as 10 volts, as you are seeing in the screen of your computer or your screen telephone, total does take a certain amount of time. By reducing the voltage to 2.2 voltage DC current or direct current, for instance, the range of changes is smaller. It takes less time, and the microprocessors can do more. Students, by decreasing the voltage of a microprocessor from 5 volt direct current to as low as 2.2 volts, Intel and other manufacturers were able to dramatically increase the speed of their system. Another benefits of reducing the voltage is that it reduces the amount of power needed to run the computer, very important for portable computers, and reduce the heat generated by all these transistors. Okay, students, let's go ahead. The next one, students, integrated circuit. What do you think, students? What's integrated circuit? Have you heard the name of IC? In the technology, maybe some worker or workshop worker say to you your telephone IC doesn't work, or your IC your telephone IC must be replaced because your telephone doesn't work. Okay, students, I have used the term integrated circuit a few times in this unit, and it's time for a brief description of just what that is, or what is the integrated circuit. An integrated circuit, or IC, is a combination of electronic components such as uh, capacitors, and resistors. An IC is designed to fulfill some logical functions and can be built to be a timer, uh, a counter, a bank of computer memory, or even a microprocessor. The basic building block of an IC is a logic gate. A logic gate performs the Boolean algebra and operations by testing two input signals, mm, each stored in a transistor. If both are positive, representative, or representing true or 1. It sets the signal of a result value to positive, otherwise the value is set to negative, represents false or a zero. A student's integrated circuit is familiar with you, and usually it's used in the electronic devices, and without that will be there will be a lot of problem to work, and also the electrical devices will not be able to work without the integrated circuit or IC. Okay, students, let's go ahead. Okay, students, it was our lesson today. Please pay attention to your homework, and also please solve your homework and share with me in the group or in the uh, comments. But if you have any problem in these lessons, also you can contact me in my telephone number or in my email, and also in the group or in the comments. The first question of your homework, student, says, what's transistor? We completely explain it the transistor, and here's a small question, and also it has an easy answer. Please answer this question. And also knowing that transistor is important to you because you will be a computer engineer or the hardware engineer in the future. But if you don't know the transistor, you will not be able to knowing how a microprocessor or CPU works. Okay, students, let's go ahead. The next one is, what's the main job of a transistor? When you uh, define the transistor, also you must answer this question: what's the main job of transistor, and what is doing the transistor in the computer or in the processor? Students, is however we answer this question in the above page, but for more information also we said please see in internet, and also search about them in the internet, and share with me the result or the answers in the group or in the comments. The next one, students research about the IC or integrated circuit. Students, it's also IC, knowing IC, and also knowledge about IC is important. Please research about that in the internet, or if you know something about IC yourself, also it's enough. But if you don't know anything about the IC, please research about them and share it with me in the group or in the comments. Okay, students. Tomorrow we will have a discuss about the parts of processors, and because this section also is important, and we will have a completely discuss about him tomorrow. Okay, students, that was our lesson today. Thanks for your watching. Have a good time.